Welcome back, welcome back, welcome back. I'm Miss Lisa, and this is my YouTube channel where we talk about everything I want to, science and math. And today we're talking about physics, and in particular, electricity. In our last video, we talked about static electricity, which is like when you get shocked on the doorknob or lightning. And now we're going to talk about current electricity, electricity moving through wires. So this video is probably going to be kind of short because for the bigger video will probably be the math one maybe this time, because a lot of this is math, and we're gonna need to turn the camera around so you can see up close what I'm doing. And that's not hard math, it's good math, you'll like it. So another thing I was going to tell you is we are only going through chapter 24 in this book. The rest of the book is more advanced level, and also chemistry, which supposedly you've already had, so you don't need to we don't need to waste time doing that again. They always put extra stuff at the end of the book so that public school teachers, if they got ahead and they need something to fill a couple of weeks, you don't want the kids just bouncing off the walls getting in trouble, so we can review chemistry is what they threw in this book. But there are parts of science that both chemistry and physics claim. So it's in both books. So hopefully you learned it in chemistry, because we're not going to do it in physics. Go back to my chemistry class and you can watch those videos if you want to do that. And if you want to do the rest of this book, do it. There are plenty of YouTube videos and that would teach all of it to you. So current electricity. Now we're talking about electricity going through wires. So the idea of a current, of a stream going along, really is a good model for electricity moving. And the book starts off showing where you see those transformers and power stations, and it talks about how we move electricity to houses, to businesses, and that we run on electricity. I'm videotaping right now on a camera that is using electricity. So electricity is very important to our society. Now then, the other thing is, that thing started squeaking. If I see Eli, I'll tell him to make it quit. But for just a minute, try to ignore it, okay? It's my dryer. It still dries clothes, so it's hard to get rid of it. But it just started squeaking, and we tried to fix it, and it's still squeaking. And it just does it at random. So like it was okay, and I'm like, I'll let it run. And it's starting to make that terrible noise again. You can fast forward if it's bothering you too much. Because what I'm going to say, I'm going to repeat at the end. Those power stations, what they do when they take the electricity to your house, they do it at high voltage and low current, and it prevents losses. And it's also safer, because it's actually not the voltage that kills you if you get zapped by electricity, it's the current. So it's really safer to have a low current. Now then, let's see. So we're gonna, in the next video, and you're like, I'm so glad this video is gonna be short as long as that thing's squeaking. Oh, sounds like it's about to quit. Anyway, in the next video, we're gonna talk about how electric circuits are diagrammed. I'll show that to you close. But on this video, I want to talk to you about how electricity is made. How do you make electricity? What if you were in a time machine and suddenly you got taken back to the 1700s and you want to show people how to make electricity? Would you know how? This is how you do it. Electricity is made by magnets. It has to do with magnets. If a magnet moves near a wire, it generates electricity into it. And so that's how electricity is always made. Here in Georgia, we have a hydroelectric dam. It is very green. People love a good hydroelectric dam, because what makes the electricity is water falling. When the water falls through the dam, it does what's the equivalent, and if we were face to face, I would get out my Winnie the Pooh pinwheel and everybody would blow it, and it would turn around and around. And all you're doing is, to make electricity, you have to have some way of turning a pinwheel, because that's going to move the magnets near the wire and make the electricity. So one way to do that is by letting a hydroelectric dam, as you release the water, it goes over the pinwheel, moving the magnets and making electricity flow through the wire. Another way to do it, and where most electricity comes from in our country, is burning coal. So like in our homeschool group, we did a great field trip. You should do it too. We went to Georgia Power to a field trip of the power company up in Rome, Georgia is the one we went to, and we got to see them making electricity, and they were burning the coal, and we got to look in the oven at it, and then they were making the electricity, and we got to see that, and it was really interesting. And what you do is, if you're burning something like coal, they use it to heat up water. The water makes steam, the steam blows the pinwheel. Also, nuclear power plants, like where Homer Simpson works. There they use nuclear rods, and they have these things that absorb the extra radiation. They pull them out to let the radiation out. Radiation's hot. It causes that heat of radiation boils water that makes steam, that blows the pinwheel, that moves the magnets, that makes the electricity. So what about wind? Same thing. Wind blows the pinwheels, moves the magnets, makes the electricity. And solar is one that's different. Solar is more like batteries. Batteries use a chemical reaction, or called a redox reaction, an electrochemical reaction that makes electricity. Well, solar is more on those lines, and if you want to understand that, take chemistry and understand the redox reaction, the electrochemical chemistry chapter. Okay, so you're going to learn the parts of an electric circuit. Think of it as a switch, a wire, and a battery. That's your electric circuit. But it could be a plug. Now, if you have, it's doing it again. If you have a plug in the wall that's AC current, and what it does, instead of the electricity just flowing, it jiggles back and forth in the wires. And we can use that to run all of our electrical devices. The other kind is direct current, and that's with a battery. It only goes in one direction. And that's DC current. So like the band AC/DC is named after electricity, I think. I've heard other things, but I think it's electricity because they're an electric band. All right. So now there's three parts to electricity that we do a lot of math with: resistance, voltage, and currents. And resistance equals volts over current, and that is called Ohm's law. So Ohm is the guy who thought of this, and his name is the unit of resistance. I used to show my old physics class I used to teach, and there was a sign that said, "Danger, electricity." And then it said something like 1,000,000 ohms. Well, 1,000,000 ohms wouldn't kill you. It's resistance. It's the opposite of electricity. So they didn't know what they were talking about, whoever made that sign. Okay, so in the book we're going to talk about how this is diagrammed, how we do the math on it, and then we'll talk a little bit about using electrical energy. If you like electricity, there are jobs in electricity where you can make a lot of money. You can be an electrician, but you can also be an electrical engineer. They start after a 4-year college degree at $120,000 a year. It's just a crazy amount of money. Way more than I make as a public school teacher, I'll tell you that. Double. All right. So how is electricity purchased? We buy electricity in watts. You pay for it in watts, and that equals joules per second, because joules is a unit. So what is a unit of power? That is how we buy our electricity. You can read more about that in your chapter about how it is measured. So we don't really have a very good lab for you in the book this week. What you can do for your lab is a couple of things. One is if your dad or mom has a multimeter, you can get it out and mess with it and figure out how it works. Watch some videos on it. That would be useful. You could find something in your house that needs repairing with electricity, and with your mom or dad's help, you might could try to repair something with electricity. You can watch some videos on electricity. You can make some circuits, actually. If you get a battery, you can use aluminum foil and fold it, and it will conduct electricity. You can put it on a piece of cardboard and make a little circuit, and you can get a bulb out of a flashlight, and you can do some experiments with that. What we would do in my class last year is I had a flashlight that you would shake, and it would move a magnet in a coil of wire, and it would make electricity. And so we would mess with that electromagnet. You can make an electromagnet with a coil of wire, a battery, and a nail. Very fun. All of those kind of experiments, there's a lot of ones that are fun, little safe experiments you can do at home on the internet. I'd say go look through them, find one that looks interesting to you. I think making an electromagnet is very fun. You can try that, or you know, there's other things you can do. So I'm going to sort of leave lab up to you, because the one in the book is not very good. It's a little too physics specific. All right, so like, share, subscribe, come back for part 2, and we'll do the fun part, the math. Remember, science is great.